Hi there, Ms. Lambs here. In this video, we will talk about microbiology in pour plate method as to how we convert bacterial colony count to what we know as CFU. So it's colony forming unit. Okay, usually we measure in CFU per cm cube or CFU per mil. Just a disclaimer, I'm not an expert in microbiology. Here's just some very brief general guidance. So please feel free to research further. And this video is made around July 2022. So here we go. So in this summer, we went to the IB teacher forum, and one of the things that they talk about microbiology is that we should stretch students' ability as much as possible. So here comes the calculation of CFU per cm cube, okay, when we're reporting the colony count. Okay, just bear in mind the fact that colony count as the final dependent variable is also accepted in IB so far, okay? So far, there's no penalization based on the return. However, if you research a little bit more, you will come across CFU as a common way of reporting microbiology in scientific papers. Okay, before we move on to the calculation, I just want to remind you what are the suitable bacterial colony counts. If you research a little bit more, okay, some scientific research will accept a range around 30 to 300 bacterial colony counts. However, in practice, we'll recommend you to have less than 200 bacterial colonies per plate in order to avoid what we call miscounting. Okay, so just some suggestions. All right, so how do we do the colony forming unit? Okay, CFU per cm cube. Sometimes you will come across a CFU per mil. Both are accepted. The formula for that is actually colony count on that plate times the total dilution factor. Okay, close bracket, divided by the volume that you use. Okay, so let's see some of the examples. Okay, before we move on to the example, just want to clarify something that is called dilution and dilution factor. Actually, they mean totally opposite things. Okay, so dilution, as you can see here, is a volume of stock solutions, okay, divided by the final volume, okay, so which includes the diluent volume. So that is the, for example, sterilized distilled water plus the stock volume, okay, so that's the final volume, okay. Whereas for the dilution factor, it's actually reversed. So it's final volume divided by the volume of stock solution transfer. So in this case, okay, so for example, this stock solution will transfer 1 ml into this boiling tube, okay, and then plus inside the boiling tube you have some sterilized distilled water, okay, so and then you mix them. So then in this case the dilution factor is 10, okay, so 10 divided by 1, 10, and meanwhile the dilution is 1/10, okay, so 0.1. So dilution factor 10, dilution 0.1. Okay, now here is some reference, okay, about how we deal with the dilution and dilution factor. So you can feel free to research a little bit deeper. I will put the video description in the, video link, okay, in the video description below. Okay, all right. So moving on to the next one. Okay, so this and if you dig deeper, okay, you will come across a term called total dilution factor. So if you dilute by once, okay, so 1/10 easy. Okay, so what happens if you dilute by serial dilution to get to a very, very diluted solution, which is very common in microbiology. So for example, if you dilute once, okay, so 10 dilute by 1/10, okay, so dilution 1/10. The total dilution factor is 10, easy. Okay, so if you take tube A's, 1 ml of tube A's, and then add into 9 ml of distilled water, which makes up to the tube B, then your dilution will be 1/100. Okay, so 10 to the negative 2. Whereas the total dilution factor will be 100, and so on. Okay, and in this picture, you can see that they also include a question. For example, for tube D, okay, and turns out that you have 443 colonies here using 0.1 of tube D. Okay, what will happen? What is the CFU for tube D, E, and F? So you can pause the video and try this out. Okay, so again, you use this formula, bacterial colonies times total dilution factors divided by volume. And here is the result. Okay, so plate D, okay, so relatively large number, which is very common, okay, in microbiology. So 4.3 times 10 to the power of 7 CFU per cm cube, okay, and so on. say E, and say F. Okay. All right. Another example. So for example, 42 colony count, concentration of 1% bacteria. So dilution factor is around 100. Okay. So volume that you would be using micropipette. So 500 microliter. If you convert back to cm cube is 0.5. And use this formula, and turns out it would be 8,400 CFU. Okay, so very, very easy. Okay, so I hope you will find this video useful. Add oil and bye for now.